So acceleration can occur because of a change of speed, or because of a change of direction, or in fact a combination of the two. So off on the left here I have the simple cases that we've considered in 1D motion. This one shows a motion diagram for an object whose velocity is increasing towards the right, and its acceleration is therefore pointed in that direction. And so remember, delta v points in the same direction as the acceleration. And so if we delta v we can do by taking v2 minus v1, and so if I take v2 and I subtract v1, I will actually get a vector that's pointed in that direction. Make sure you understand this little vector drawing here. In the second case, also 1D motion, I have a motion moving in 1D, but its velocity is decreasing as it goes towards the right. The acceleration is pointed towards the left, and v2 minus v1 is this vector minus that vector, which is in fact a vector pointing backwards. And so delta v again is in the same direction as the acceleration. Now over here there's a new scenario. This is an object that is moving at constant speed, but the velocity is changing because its direction is changing. And so what I'm meaning to communicate here is that there's a circle on which this is moving. There's a dotted line that I drew, circular dotted circle. And then I made symmetrical points around the periphery of the circle, and a motion diagram then takes me from one point to a second point to a third point. And so this would represent V1 and this would represent V2. So in order to compute V2 minus V1 for this uniform circular motion scenario, here is minus v1 here, and so I'm simply going to add minus v1 to v2, and I'm going to get this green vector delta v, which is going to be in the same direction as the acceleration, and it is pointing towards the center of this circle. And it is pointing towards, approximate towards the center in my picture, but if you make the intervals on which you're tracking the velocity. In other words, if you put a lot more points and all these little velocity vectors get smaller, this delta v will point with increasing accuracy towards the center of the circle. So if you think about this in the context of a car, for example, there are three ways, crudely speaking, that you can accelerate the car. There is the accelerator. That corresponds with this. There's the brake. That corresponds with that. And the third way you can accelerate the car is with the steering wheel. That corresponds with this.